My name is Peter Spragata. I'm Senior Principal Engineer, formerly Ansible, now Ansible by Red Hat. Came from the networking industry, well over 20 years, network engineering, network operations. But prior to that, my first job out of school was, I was a mainframe developer. S370 running TSO was my first development workstation. So that's kind of a little bit about kind of my background. But one of the things that's always been exciting to me is I've always loved doing software development, and I always loved doing network engineering. And I'm watching these two worlds start to come back together, and it's pretty exciting to really be part of it. So I'll talk a little bit today about what we're doing at Ansible to really start to bring IT back into the bigger sandbox of IT orchestration, IT automation. I think that the network has traditionally kind of just sat out there by itself doing its own thing, and still by and large does to a degree. But I don't know as if that needs to be the case anymore. And we'll talk a little bit about the hows and the whys and whatnot. I'm curious though, for the folks in the room, especially given this is Red Hat Summit, how many folks in here are actually directly or indirectly responsible for their network infrastructure? Oh wow, that's excellent. That's a lot more than I thought I would see. Fantastic. Well, good. So I'm going to talk, as we kind of go through this today, I'm going to try and talk to it to both sides of the house here. I'm going to talk to it to the traditional networking side. We're going to go on a little journey today. I'm going to show you what's behind the big curtain, as it relates to networking and how network infrastructures are built, and we'll talk about it from network engineering and operations, as well as from a more kind of a developer or a DEVOPS, if you will, type of vantage point or context. So to get started, I think we need to define where we're at, and especially when I'm out talking with groups that don't have an extensive network engineering and or network operations background, right? We always see the network depicted in software diagrams as the black line that connects, right, all the functional diagrams together. And while that works when we're describing the network or we're documenting the network, in reality, right, what's behind that big black curtain is a substantial infrastructure of software running on top of an operating system that's running on top of hardware. And I like to phrase it that way because in reality, right, network devices, even though they tend to contextually be a bit odd, those of us in the networking industry, we have a strange nomenclature and we use funny words and we love our alphabet soup. The reality is that a network device is nothing more than a computer running an operating system with applications on top of it. So therefore, when you start to think about it like that, you start to realize that we can take traditional software methodology and apply it to the network space and actually start to do some very functional things. Now, I'm always cautious not to go down this is SDN path, because this is not what SDN is, or at least not how I would define SDN. Really what we're going to focus on is really how we can start to automate and orchestrate these network devices and do it in a way that encompasses the application stack as well. So it probably makes sense to start by defining what the network really is. And this is kind of how I've always defined the network. And I really kind of define it in two different ways. The network is a provider of consumable resources. I think we all understand this part, right? I can go to my network team, I can go to my operations team, say I need a port, I need a VLAN, I need this, I need that, and 6 months goes by and I call them back, and a few more weeks go by, and finally all of a sudden it's provisioned, and by then I've completely forgot about the fact that I made the request. But the reality is that it is a platform, or it is a provider of consumable resources. But it's also a platform for running applications, and that's what we're going to talk about today. The network is really, like I said, it's a hardware platform. It runs applications, and those applications just happen to be distributed in nature, right? So we can start to apply a lot of the methodology of managing and orchestrating distributed applications to the network platform. But it begs the question of why go through this? And a lot of studies have been done on this, and I think that when we see what's happened in IT over the last, just in the last 6 months, let alone the last couple of years, right? We've seen this explosive growth of hyperscale data center infrastructures. And we've seen a lot of methodology shift to utilizing tools like Ansible to ultimately help with dealing with just the voluminous amount of work that comes along with trying to manage a lot of these hyperscale infrastructures. And we're talking about, right, the deployment of massive compute infrastructure to handle explosive application growth. However, what's kind of been lost in the shuffle is networking, right? And I touched on it a little bit before. Networking has kind of always sat over in there in that corner, and they just did their thing, right? Requests came in, and some guys went in the back room, and they huddled up, and they churned around, and suddenly output came out. And no one really knew what happened back there. And to be quite honest, most people don't really care what happened back there. All they cared about is, how do I get my two endpoints talking to each other? So what we want to do is we want to start to open that up a little bit. We want to start to, figure out how we can expose that, from a automation standpoint, so that networking is not sitting there and people are wondering what's going on and why is it taking weeks to provision things when they really should be done in seconds, if not faster. So we start to ask ourselves, what does change management really look like today from a networking standpoint? So I just pulled out, some of these, and these are all kind of, I guess, quotes, if you will, or words that I've heard expressed by, folks that I've talked to in the industry. And it really kind of shows that, networking is just kind of stuck. It's stuck in this quagmire of how do we move forward? How do we start to be able to automate and provision at a rate that keeps up with the need for building out application infrastructure. Especially when we start looking at things like building immutable containers and microservices and the need to build these services faster than ever. We can't be dealing with the fact that we have an error-prone change management process, or that we have a superhero culture. And what I mean by that is we've got a team of networking specialists that do everything, right? We need to start to turn to software, and we need to start to utilize software to infuse new policies, new methodologies, and new procedures into how we manage and build out our infrastructures. So the first one I key on is the fact that most processes are manual today. We're going to talk a little bit about this here in another slide, about why this is such a big problem. Certainly, there's a problem in the fact that it's just slow, but it's also, it brings on the fact that errors happen. We've all seen some of the high-profile cases that have shown up in regulated industries about organizations that have had outages. And I won't go into any specific names, but it doesn't take much Googling to find, one or two where, they've had outages because of manual change management. Uncoordinated. This is probably the biggest problem we're trying to solve today with utilizing Ansible and extending full-stack automation. Network change management is happening in a vacuum today in most organizations. It's not happening in conjunction with the deployment of applications and services, and we need to figure out a way to start to bring all of this together. There's no reason why we can't define network resources as part of the application blueprint for when we spin up and spin down workloads, and be able to have the network automatically be provisioned as part of that process, just like we provision all the other components. The last one, and this is for those of you in the networking space, is validation. It's not sufficient anymore to just simply push configuration out to network devices. We need to be able to validate that the network is giving us what we expect it to. And this was a big area of focus around how we wanted to start to do extend automation into physical network infrastructure. The reality is that when you talk to many network operations teams, what you start to find out is that they're behind the times, right? They're still doing automation the old-fashioned way. They're logging into boxes. I mean, when you find a network operations team that has even implemented SSH keys, you found a progressive one. So it gives you a sense of what you're working with and what we're trying to automate, some of the problems we're trying to solve. Because the reality is that the network has always tried to hide behind these ideals that they're somehow different, they're somehow special. They carry all the applications, so they've got to do things that are different than everything else in IT. And my feeling is nothing more could be further from the truth. we can start to apply methodologies and concepts from CI/CD pipelines in terms of how we do application deployment over to the network and start to utilize a lot of those lessons learned to get much more efficient at how we do change management on network devices. So I like to talk about this idea of DevOps meets NetOps. Now, I'm not a big, using of the word DevOps, but I like to throw it out here because it at least puts a picture in folks' head. The idea here is that we need to start to, if I could steal from the political speak of the day, we need to reach across the aisle, right? We need to start to work closer together amongst these organizations to really deliver automation, really deliver full stack automation. We're going to get into what this looks like, and I'm actually going to show you some of this running on a live system here in a little bit. We'll actually look at what Ansible is doing to really drive this. But the idea being is that we've got a significant amount of methodologies that have been developed in terms of how we need to orchestrate and or automate applications, compute infrastructure, storage infrastructure, cloud infrastructure. We need to take that information, we need to take those lessons learned, and we need to start to apply it to the networking space and do it in a way that creates safety, right? That creates an environment that allows us to get these applications pushed out without melting down the network in the meantime. So I love to talk about from MOP to playbook. And for those of you who have never been in the networking space or have never been very specifically in the telco space, which is where I got my started, I'll share with you a real quick little story. Back in the days of the phone system networks being built, this actually goes back to my first job in networking. I used to install TDM switches for Lucent. And the way that we did change management back then is we would spend anywhere from 6 to 9 months writing a book. This thing was 300, 400, 500 pages. We called it a MOP, a method of procedure. This MOP would have everything in it in terms of how a change needed to be made, what commands had to be run, what devices need to be connected to, how to interpret the results of those devices, what to do if something went wrong, who to call, how to test it. Everything went into this document. Over time, we would then test and validate that document. And once we were satisfied with the change, it would then be turned over to operations for ultimately to be implemented in the telco space. And a network operations engineer would take that document and he would follow it line by line, step by step, all the way through to the conclusion. And if all went well, he would have a successful change in his network. That's how we did change management in 1979 for telco switches. Not much has changed. I can tell you that I've talked and worked with some very large network service providers in the world, and it's exactly how they're doing change management today. When you place that ticket that says, I need an access port turned up, I need a VLAN, I need more resources added so that my application can perform at peak scale, what's happening is on the backside, this process starts all over again. A network engineer gets this information, and he starts writing a document. And he builds that document till the point where he's happy with it. And then he turns that document over to operations. But something interesting has changed. This is the one slight change that didn't exist back then, is that because now we're working with routers and switches and interfaces that we can more easily adapt to a graphical interface, what that guy's doing at 2 in the morning is he's doing copy and paste of commands. And boy, oh boy, help us all if he does that in the wrong window, because we got a real problem in our hands. And that's how change management is done today in network infrastructure. That's how applications are deployed on network infrastructure today. So we want to move away from that paradigm. We want to start to move to, instead of writing MOPs and dealing with copy and paste and in all of this business, we want to start to utilize the concept of playbooks from Ansible to automate that change management. We get some really great benefits along the way. First and foremost, we get the benefit of the fact that Ansible can start to separate the data model from the execution of that data model. This is the key to ultimately achieving full-scale automation in the infrastructure that includes the network. The problem with networks today is the fact that we don't do a good job delineating data model from execution of that data model. You talk to a network engineer or you talk to a network operator, and most of them will tell you, I do IP address 12345/6 or whatever on my interface. And what he's just done is he's just munged together his data model with executing on the device. So with Ansible, we can start to create that separation. We can start to build a data model and manage the data model. Because in reality, that's what makes our network ours. It's not, I've got this device from Cisco and that device from Juniper and another device from HP. That's not our network. Those are the devices in our network. No different than, if I've got Intel processors or ARM processors or whatnot for my application. So that's how we can start the process of being able to move away from manual change management. We can also start to create a common language. And this is where the one area where DevOps starts to make a little bit more sense. Because now, instead of trying to figure out how the network team talks with the application team, we can start to have a common language around automation, around the Ansible playbook. And that's really what this is all about and what this idea is all about. So it's not, the networking team talking about, VLANs and port channels and interfaces, and then on the application side, we're talking about, instances of applications and services and bonded interfaces, right? And the two never can seem to talk. We can start to coalesce around a playbook. However, in order to do this, Ansible had to take the approach, or even generically speaking, automation had to take the approach to enhance network operational models. It could not be, and it still cannot be, a situation where you take 20 years of organic knowledge in terms of how to operate a network infrastructure and throw it out the door. We have to be able to enhance the operational model in a way that the networking teams can make use of the tool as they start to integrate into the automation pipeline. And that was the key of what we started to put together. So what are we really talking about here? So what I wanted to do is I just wanted to grab a quick network config. We're actually going to look at some on real here when we actually go in and look at this from a more demo perspective. But what's interesting about this is that for those of you who have never seen a network config, imagine, especially those in the application of the systems world, imagine if on your server that's running OpenStack, that's running some kind of authentication, that's running applications, that's running whatever that's running on your infrastructure, you get one comp file. That's it. Every setting you need goes into that one comp file. That's what network folks are dealing with every single day. They get one comp file. So, I did some back of napkin, just kind of scribbles at one point. Unfortunately, I didn't bring it with me. I should have built a slide on this. It would have been interesting. But, I roughly came up with a number of a small to mid-sized data center. I'll describe a small to mid-sized data center is, anything that is less than 10 racks, okay? That's a small data center. Small data center, from a networking perspective, that's building both underlay and overlay infrastructure, is roughly around just shy of 1 million lines of configuration from a network perspective. 1 million lines. I can't imagine what it must be like to do change management in that environment in a manual way. You've got to change 1, 2, 3 lines. You've got to make sure that not only does the change go onto the right device, not only is the change reflective of the right application, but that the change can then be tested, can be validated, both before and after the deployment. That's a lot to ask for without having the appropriate tools in place to handle that. So how are we going to do this? There are 3 key areas around how to enhance network operations and ultimately to be able to extend our automation stack beyond the compute infrastructure into the network. The first one is this idea of configuration automation. I think it kind of goes without saying, if we can't get this part right, the rest of it almost doesn't matter, right? We've got to be able to reliably push out configuration to end devices. But as I kind of touched on earlier, we want to focus that delivery, the delivery as it relates to Ansible on executing on those end devices so that the networking teams can go back to managing the data model. As I tell networking engineers, we want to give them the opportunity to go back to being a network engineer, go back to doing the whole reason you got into this business. It wasn't to punch out CLI commands, at least I hope it wasn't. Right? It was to look at holistic system problems around the network. It was to look at performance management. It was to look at evolving the infrastructure over time to support new and better applications, to support more efficient applications. So we don't want to break what was broken. We know how to do this from a manual perspective. We just want to find a better way to do this. The next one, and maybe the most important one here, is this idea of test-driven deployment. This is the one we're going to talk about, or I'm going to actually show you in a demo here when we get into it. But we really want to start to tap into the ephemeral state for validating network change. You know, as applications and services have shorter and shorter lifespans, and we're able to spin up workloads and have those workloads perform a function and then shut themselves back down, it becomes even more important that we start to tap into that ephemeral state information and utilize that information to understand, are things operating at peak efficiency? Are things configured properly? Are we achieving the desired effect that we need to in order to support the application infrastructure? I love to think through a story. I saw this happen in one particular network, and we were looking at some trends over time. And this was an explosive growth company. They were moving off bare metal into a virtualized infrastructure, and the application development team was just pumping out application after application as they moved it off bare metal onto virtualization, and they were accelerating at some pretty significant paces. As they would go back and look at their applications and they would start to profile those applications, what they were seeing is they were seeing a significant reduction in the performance of those applications. Over time, what they began to realize, as many organizations do, is that going from bare metal to virtualization, they were over-consolidating, and effectively they were exhausting CPU and memory resources on their compute infrastructure for their application. So they did what any good application team would do. They started to distribute their applications more in the infrastructure. The problem here is that they didn't involve the network in that discussion. So as they are creating more distributed applications in their infrastructure, the network team is seeing hotspots show up in their network, right, where they didn't used to have hotspots, right, because they had planned for a very static style infrastructure. Of course, network team does what they do. They start building more bandwidth. So when you watch this trend happen over a period of time, what this organization looked back and realized is they realized that they were creating a significant amount of capital investment because you had two teams that weren't talking to each other. Application guys were creating more and more virtualized infrastructure and just spreading it out, and network was responding by creating more and more bandwidth. When we get these two to start talking together, what we start to realize is that we can start to build a more optimized infrastructure. We can utilize ephemeral state to understand these types of patterns, and we can plan for them in real time as we're moving workloads around. The other big key to this is the fact that we need to be able to fail fast. This has always been a big tenet of Ansible, right? Fail fast. We need to be able to, if something's going to fail, if an automation deployment is going to fail, we need to get out of it very, very quickly. An ephemeral state is what gives us the ability to do that. We can actually start to look at things and we can say, this is not achieving the desired steady state of operation that I expect. I need to get out of it. I need to do something else. The last one is this concept of continuous compliance. Of course, continuous integration, continuous deployment are great for applications, but they don't make a whole lot of sense for the network. The one area where the network does differ just slightly from a distributed application is the fact that you don't easily just add more network capacity or more network nodes to handle load, right? Networks are fairly static from a box standpoint. We got to kind of work with what we have. And, because any network engineer, network operations individual will tell you, asking for budget for the network is like getting kicked in the teeth. It's not a fun process to go through. But we do now have the ability to continuously check compliance of our network, right? Because we don't just simply add capacity, we want to continuously look at our network. We want to use that ephemeral state information. We want to use that configuration information to make sure that the network is continuing to be configured explicitly as we've designed it to be. So as we turn up workloads and as we spin up workloads and we spin down workloads, as we spin up and spin down microservices, as we add more virtualized instances to our network, configuration needs to be on those devices, and it needs to stay there until it's explicitly changed. It can't be changing simply on its own. And that was a key component of what we can start to look at. So, I want to start to, now that I've kind of set the stage about network automation and kind of where we're going with this, we're going to shift a little bit and start to talk about very specifically how we address these 3 use cases utilizing Ansible. So at this point, I'm curious, how many folks in here have actually utilized and used Ansible in their environment? Excellent, excellent. Why haven't the rest of you? No. So Ansible was built to really try and drive automation in a very simple way. The whole idea behind Ansible, and when we built Ansible, is that we needed an automation platform that didn't require a 6-month investment in learning how to turn the thing up so that I could start to do automation. It just kind of seemed very counterproductive. So one of the key tenets in Ansible was the fact that we wanted to be able to build playbooks, and this is what you're seeing here on the screen as a playbook, that is very simple to follow. Even if you've never worked in networking, even if you've never seen Ansible, you probably can at least look at that and start to pick out some things that it's doing. And that's a big, big tenet of what Ansible is all about. It's all about simplicity. Part of that simplicity is the fact that we wanted Ansible to not get burdened with dealing with agent code. When we talk to end devices, we talk to them over SSH. Why? Because SSH is everywhere. It's hard to find a device that connects to an IP network that doesn't have SSH capabilities. This especially rings true in the networking space. Networking devices are fairly closed systems. It's starting to change a little bit, but for the most part, a network device is not a device that you can go install arbitrary executable code on. It's a device that you can interface with, but your ability to work with it at a programmable layer is challenging. Now, there are some organizations that are trying to change that paradigm and shift it to being a more open, a more Linux-based device. But we need to be able to work with all of it. We need to be able to work with legacy systems as well as we look at this. So configuration automation in this case is making liberal use of roles to ultimately produce automated change on the network. So we start to look at things like BGP, which BGP is a protocol. If you've never heard of it, it happens to be the protocol that runs the internet for the most part. But it's more so than that, it's just a distributed application. So we're going to start to manage it as a distributed application. And a distributed application, like any good distributed application, is running on multiple devices. It gives us good ephemeral state information. And it gives us a set of properties and methods that we can program against. And that's effectively what we're starting to do with Ansible playbooks. So when we go out and run this, we can now define our BGP data model, whatever we want it to be. And for those of you who are ankle deep in the networking space, you probably have heard a lot about things like standardized data models. OpenConfig, for instance, comes into play. The reality is that the data model doesn't matter in as much as the organization needs to agree on what that data model needs to be. How you want to define BGP or how you want to define an IP address, as long as everyone is consistent in the organization, that's the key to managing the data model. I can call an IP address a cow if I want to. As long as when you and I talk, and I say cow, you think IP address. You think, oh, that's an IP address on an interface, right? That's what managing a data model is all about. And we don't get saddled with worrying about, oh, well, I've got Juniper devices and Cisco devices and Arista devices, and now I got to figure out how to get that data model onto the box. Ansible solves that problem. That removes the burden from the network engineering and operations team. Even more so, because we've got playbooks, and those playbooks, if I go back one, can start to define the properties that we utilize to build these applications, these distributed applications with. As a network engineer, I can start to decide what I'm going to expose to my application teams, right? Because I want to keep bringing this back to, yes, network automation is great, but network automation within the full stack is even greater. So now I can start to expose a set of properties, a set of arguments to the application teams so that they know what can be configured on the network device to ultimately turn up their applications and services. They need to add more bandwidth. They need to add more VLANs. They need to add more components. That can all now be exposed through Ansible and provided as part of the blueprint for how we deploy a new application and service. But I talked about test-driven deployment, so we're going to actually look at what I mean by that in a kind of a use case here. Test-driven deployment really kind of goes down this idea or this path that we want to push out configuration. So I want to build links to 3 different routers here. So Ansible is going to talk to these routers, and it's going to start to go through the process of building out these applications and services by pushing configuration onto the box. So we build out the first link. Everything looks good. We push the config on. We've got two ends of the device are happy. We've got connectivity going, and now our application works. However, here is the fundamental problem with configuration automation as it relates to network right here. Configuration in this case, as we push it out, is going to be just fine, right? I'm going to be able to configure both sides of that link. I can put IP addresses on it. I can put VLANs on it. I can put anything I want on it. One big problem. Someone forgot to plug the cable in. There is nothing in configuration management that's going to solve that problem for me today if I don't start looking at ephemeral state information. And that's how we get to full stack automation. We have to start looking at what is going on after configuration is pushed onto these devices. But we have to do it in a way that augments the network operations team, as I said before. It cannot be, having a network operations team sift through page after page after page of API documentation, because I can guarantee you they won't do it. Network teams don't care about programming. They don't want to write scripts. All they want to do is engineer the infrastructure. So we tried to create, and we've been very successful in creating a set of constructs in Ansible that actually allow us now to start to do this, but do it in a way that augments the way they're already performing a lot of their duties. What I mean by that is that network teams have, if you remember going back to the MOP discussion, right? They have a whole set of commands available to them. Right? These are commands they run in SSH sessions to the box. These are show commands and CLI commands, and you probably have seen or you've even done them yourself. We start to actually utilize that information so that organizations don't fundamentally have to change how they orchestrate or how they push configuration onto the devices. What we do is we give them an environment by way of automating it. And then last but not least is now that we understand what needs to be pushed to the device via configuration management, now that we are testing it as we push that configuration out, we want to go back and we want to continuously be looking at this information. We want to say and be able to say, are all my applications and services communicating properly? Right? Has someone come along and done something to my network that is no longer going to allow my applications and services to operate at peak efficiency? This is where the idea of continuous compliance comes into play. We can start to utilize that same data model and continuously evaluate what's going on in the infrastructure. Continuously look at what's going on and make sure that our configuration is still in force unless we've explicitly removed it. Thank you so much for coming this morning. I really appreciate your time.